Charles' law basically states that volume is directly proportionate to temperature, right? So if the temperature increases, then the volume will increase. If the temperature decreases, then the volume will decrease. So here's the equations for Charles' law. So there's V1 over T1 equals V2 over T2. And then you could also say VI, which is initial volume, over TI, which is initial temperature, equals VF, so the final volume, over TF, the final temperature. So if I go to this simulation and add 1 pump of gas particles and hold the pressure at constant, we can see the pressure is held at constant as well as the amount, right? No particles are being added after this point. And let's add width. So you're going to see as I increase the temperature, this volume right here from 10 liters is going to increase. So as I increase the temperature, the volume is going to increase, and that is because they are directly proportionate, both volume and temperature. We see that pressure hasn't changed and the amount hasn't changed either. So if I cool the gas particles, we can see the volume is decreasing along with the temperature. Pressure is still the same and the amount of particles is the same. So we can see that this is a linear relationship. We can see that the independent variable is the temperature because that is what I'm changing. The dependent variable is the volume, and the pressure and the amount is what is held at constant, or what is called the controlled variable.